Well, welcome to Emerald Hill Skies. We've been away for a while. These cloudy skies are annoying, aren't they? I think the last time that we streamed was the night of the Messier Marathon. And you might recall we were able to cover a lot of the 110 objects of the Messier catalog that night. Since that time, we've not really had a single cloud-free night, moonless or otherwise. So it's good to have you here tonight. I just thought that we probably should start by taking a look at the sky cam. A while ago, I was noticing a lot of clouds down here in the lower horizon, but now, thank the Lord, they seem to be dissipating. So that's good news, isn't it? All right, let's see. Looking at our scope cam, you might notice that we're using a RASA 11, and it's 11-inch aperture. And you know, this RASA 11 is unique because it doesn't have a place to put an eyepiece. All it's got is a place to put a camera. So the camera we use is this ZWO ASI2600MC Pro. It's a color astro cam. You can see it's attached to a Octopi-Astro camera interface, and then it's attached to the corrector plate glass on the very front, the top of the scope. So here's a picture of the scope, and if you look toward the top, you might just see that black, I guess you'd call it a dew guard to keep the dew off the scope. And underneath that dew guard at the very top, the black portion, that's where that camera's mounted, and you can see exactly what we're seeing tonight. So it's kind of like team astronomy, huh? It's sitting on top of a Pier-Tech Adjustable-Height frame in a Pier-Tech 2 observatory, and this is a roll-off roof observatory. So the roof, as the name says, literally rolls off the whole building, and then we use that adjustable height pier to raise the scope up so that it's actually pretty much even with the top edge of the walls. And what that does is gives us a pretty good view of the horizon, down to like 4 or even 3 in some places degrees above the horizon. And you can see in the back some of the time we have trees around us, but even so, they're usually just 10 or 15 degrees tops. So it makes for a lot of fun. Now in this picture, which we took just before dusk, you can see we have some lights on the observatory. Most of the time it is pitch black out there, but even though it's pitch black and there's not even a moon tonight, maybe you can see that this night vision camera does a really good job of just using starlight, I guess, and some of the light pollution to be able to show you the movement of the scope. So let's look at our screen and kind of get oriented here. Here is SharpCap, which is the imaging program we use, and right now we're pointed in the direction of north celestial pole pretty much. To kind of get our bearings, let's go to Stellarium. Why am I not? Oh, there's way over there at the end of the line. Here's Stellarium, and we'll use Stellarium, which is like kind of like being in a planetarium, right? We'll use Stellarium to kind of keep our bearings in the night sky, since we are operating from indoors via a fiber optic relay. So we're actually not in the observatory. We're about 200 feet away from it, inside a building here at Emerald Hills, and that allows us to be able to operate on a damp, cold, or a snowy night. We can operate in good shirt sleeve conditions. Now tonight it's not too bad. Temperature 64 out there, so that's not really a very, that would be a nice, pleasant evening to be out. But this is the way we have things set up for tonight, so we'll just roll with this. If you look very close there, you can see a red rectangle. There goes a satellite. I wonder which one that is. That is a, oh, I missed him right there. Right there he is. Starlink 2120. These Starlink satellites are enabling telecommunications, I think, so satellite phones. Anyway, you can see that our scope is pointed right at the North Celestial Pole, so basically over here, and then here's Polaris. A little bit off of the North Celestial Pole. This green line represents exactly the halfway point of the sky. So tonight I thought we would get started by trying to look at this UNIONS 1. And over here on the right, I'm using Astro Planner as our targeting software. So what I'll do is just click on the object that we want to see, and then up here at the top I'll say slew to object. And then the telescope will start moving, Lord willing, in the direction of UNIONS 1. It's not really very far. Okay, some kind of new warning there. It's not really very far from the North Celestial Pole, to be honest, but you can see it, the scope moving a little bit. Now that's live. I'm going to look over here in the stream. Oh, we got Stan on from Two Rivers Observatory. Thanks, Stan. It's been a bunch of cloudy nights. Ray, good to have you aboard from Arizona. And Larry, now you've probably got your scope out, don't you? Ricky, good to have you on board from Florida. Somewhere around 10 folks observing with us. You can see the scope is pointed almost straight up. Let's see if we can orient Stellarium with the telescope now, and we'll see where we're pointing. If I click this button up here, right here, wonder why that's not working. Not real sure why it's not orienting. I don't think this object will be in Stellarium because it's kind of a new object. This was just discovered in the fall of 2023. But let's search for it just in case. It would be called UNIONS 1. UNIONS 1. Ah, it found it. It's also known as Ursa Major 3. It had to do it. It had to look it up in Simbad. Oh, I see. That's it. Right there along the meridian. So it was already oriented. Okay, to kind of get our bearings on where we are, we're pointing at pretty high in the sky. See, that's set on, yeah, that's correct, 1043. Why does it say 4 degrees there? That doesn't make sense, does it? It's just not correct, huh? Well, I don't exactly understand what is wrong with, yeah, Stellarium should be connected. It's always connected to our scope. I wonder if we're about to hit the, if we're about to back over the meridian. Yeah, there goes the line. So if everything works correctly, our telescope should decide now to do a meridian flip, I think, because it's very close to the, yep, there it goes. So the telescope auto-senses when it's about to cross over the meridian. By meridian, we mean straight up. And it's pretty cool because it auto-senses that and then flips around. So now it can be what you call Pier West. You can see it's switching around. The view that we're using for the scope is pretty much just looking straight up toward the North Celestial Pole, kind of over the shoulder of the telescope, so to speak. So as you look at the scope, the west is to the left, and you can see now those weights on this equatorial mount. The weights are now oriented toward the west, and the scope is pointing up. It's on the east side. It's pointing almost directly up. Okay, so the first thing let's do, let's go back over to Sharp Cap, and not that one, this one, and let's do a plate solve. And what we do in plate solving, you guys that are visiting the channel for the first time, I know that you guys that are regulars, you already know that, but when you plate solve, SharpCap uses its memory banks to compare the live image with what it thought it should be viewing. And if there's a difference, it tries to reconcile the two. Boy, it's sharp focus tonight, isn't it? Okay. So we're now looking in the direction directly at UNIONS 1. And let's get started here with live stacking. Let's see, next target without plate solving. Prep for imaging only. I think that's what it's called. And this is called, we'll use the abbreviation like Stellarium did, UMA3, I guess we'll say. Okay. Okay, so what we mean by live stacking, again, if you're new to the channel, welcome. What we mean by live stacking is SharpCap is going to take a 20-second exposure of the sky and then immediately take another one. And then immediately take yet another one. And every 20-second exposure, it's going to sort of lay on top of each other and average them out. And it'll make the bright spots brighter, and it'll let the dark spots get darker. Down here at the bottom, we align this black level in such a way that we get the maximum right about there, and then we put the mids right about there. Yeah. Now this is the area of UNIONS 1, right here in the middle. And you can see why for a long time astronomers really didn't think that there was any big deal about this part of the sky, because it's pretty dense with star patterns. But right here in the middle, now I don't think this is going to show up in what we call deep sky image annotation, which is where we let, let's see, plate solve only. It's where we let SharpCap identify any deep sky objects in the field of view. But I don't think UNIONS 1 is going to show up in this. But let's try it just in case. Deep sky image annotation. No. It just showed IC2947. But I wonder if we go like this and then say SharpCap DSA with our little EAA tool. We've got a good friend over in an island right off of the UK, and it's the Isle of Wight. I think it's W-I-G-H-T maybe in this case. And our good friend Pete actually programmed this little interface for us so we could do all these things a little bit easier than normal. And what he programmed here is you can mark an object in Astro Planner, click this button that says SharpCap DSA, and then with this little SharpCap tool, you can paste custom object info. SharpCap found one line of text in the clipboard but could not load any catalog entries from them. I see. So it evidently doesn't have enough information to do UNIONS 1. It's a brand new object. Let's go to the browser and just read about this briefly. Right here. And let's see. Let's say UNIONS 1. And here's the Wikipedia entry on it. Dave, good to have you aboard from Colorado. Oh, Larry's already got clouds. So sorry. Too much dew and foggy glasses. Okay, so here's this object, UNIONS 1, or Ursa Major 3, is a dwarf satellite galaxy of the Milky Way. It's the smallest and faintest ever discovered. It was found by a deep, wide-field, ultraviolet, near-infrared optical northern survey, UNIONS, that's the acronym, And it was the first object that it found. It's a collaboration between Canada, France, and Hawaii Telescope, and also Pan-STARRS. That's 2 observatories in Hawaii. And Keck provided some additional detail as well. So it was just announced in November, just literally last November 2023, in a paper. And the thing about this, I guess it's probably a dwarf galaxy of the Milky Way, is that it's so old, 11 billion years old. And it's located just 32,600 light years away. And its diameter is really small. It's just 19 light years wide. By contrast, the Milky Way is like 150,000 light years wide. It only contains 60 stars. And it's the dimmest satellite. So I thought we should just look at where this is. The thing is, we're not going to be able to actually see it, but I thought it would be fun to know that you're looking in the direction of the faintest dwarf galaxy ever detected. And what I love about this galaxy is that it is so massive for the fact that it only has 60 stars. So they predict that this high mass is the result of dark matter halo. And so it has low stellar mass, but high dark matter. And in reading about this, I read that it's probably about 95% dark matter. Let's see what this video looks like here. Now let's make that a little bigger. How can we make that bigger? Ursa Major. Let's play it again here. Milky Way, large and small Magellanic Clouds. Earth and the Sun are right there, and Ursa Major 3 is out here. You can see it's orbiting the Milky Way from way outside the Milky Way. So it's a member of our group of galaxies. Maybe this is just interesting to me. I don't know how you feel about this, because we're really looking at the direction that it is right now. I don't think Stellarium is going to have any kind of data on this. It did help us find it, didn't it? In other words, if we click on Ursa Major 3, it's showing us a location, complete with this IC2947, which is right here. So if you were to, there's the star, this star is right here, and then there's a trapezoid kind of looking 4 stars right in the middle. So right here. Here's this 3 stars and 1. So halfway between the 3 stars and that brighter star. So right here. So Stellarium doesn't give us any kind of artwork or any kind of picture of this. It's just noting the location. But isn't it fun to think that some of the stars you're looking at here are in the faintest galaxy ever discovered, orbiting the Milky Way? Mike, good to have you aboard from Georgia. Okay, I'm just going to put up observing like that we, I'm going to say we, wonder why that's not working. Maybe it's, Maybe it's messed up with some kind of new... What am I doing wrong here, Pete? Something's not... Let's go up here to the script and say Edit Run Scripts. Oh, look, it updated Stellarium Sync. Okay, so let's try that now. Let's close it and go Quick Observation. I wonder if it's updating these. I bet it is. Oh, Astro 2.3.2 has been released. Let's execute this again. Script compiling. Nil object exception. EAACP execute. Well, it's a shame that that little tool has stopped working. Let's try it again here. Okay, so it works there. Now let's open up everything again. Let's go to SharpCap Pro and then bring up AstroPlanner. AstroPlanner. Where are you, AstroPlanner? There we go. Now let's try this one more time here. Quick observation. It's not very quick tonight, is it? All right, I'm going to have to consult with Pete and figure out what am I doing wrong here. So for now, let's do it like this. We're just going to have to go, I wonder if I can say right-click. I wonder if there's a choice here to make observation. Yeah, right here. Make observation. This is not as fast as Pete's little EAACP gizmo. But we'll make it work. We couldn't actually see UNIONS 1, but we could look in the direction of it. Just something like that. All right, let's move on. Got about a dozen folks on. If you haven't yet said where you're observing from, we'd love to have you do that. Let's look and see now if we have any Caldwell objects visible and catch some of them. We do. Let's go to Caldwell C. This rose at, so let's go to this one first, maybe. Yeah. It's Caldwell 83. Oh, by the way, I just want to check one more time in the live stacking here and see if by chance anything else is showing up. Do you think some of these stars, see, we're looking at foreground stars together with UNIONS 1. Some of these foreground stars are actually part of the Milky Way, but behind it is UNIONS 1. So I just kind of love knowing that we're looking in the direction of a dwarf galaxy. You know what? I bet these real dim stars here, that is UNIONS 1. Look at that. Look at those dim stars. I remember the reading saying that it was either a dwarf galaxy with 60 stars or a weird open cluster. Let's go look at one other web page while we're here, just because we can. Let's find one that, like this. Science News, April 1st, 2024. So this was just published this month. It says, UNIONS 1 is the least luminous and the lowest mass Milky Way satellite ever discovered, and possibly one of the most dark matter-dominated systems known. It has a mass of only 16 solar masses, so that's 16 suns, 16 equivalent to our suns, you see. Consists of only 6 bright stars spread over a volume of just 20 light years across. Was likely born long ago in the early days of the universe, as it consists of stars that appear to be more than 10 billion years old. And again, we always talk about the fact that these are apparent years, because when God created the universe, he could make it look like whatever age he wanted to make it look. It was created in progress. So we don't know. The earth, we don't know any. The Bible's not a clock, and it doesn't tell us when for sure everything was created. It's in our cosmic backyard, just 30,000 light years from the sun. It has escaped detection until now due to its extremely low luminosity. So few stars, one might reasonably question whether it's just a chance grouping of similar stars, but this is not the case, because using all of the measurements from the DEIMOS system, they've been able to show, we've been able to show that these stars are all traveling toward us together using things like redshift. So what I don't have yet is a good quality map. I mean, look at this. Oh, that's an ad. Close. Oh, here we go. So this is it. And look how it's over, look how the other stars kind of overlay it. So here are, for instance, a sort of a reverse parabola of 5 stars with 2 points, and then these stars going right up the middle of it. This is actually the UNIONS 1 right here. Okay, so let's go back to our real-time view. So it's my theory that this is that parabola. Maybe. And it's my theory that this is UNIONS 1. Look how it's basically a spine. 1, 2, 3, 4, 5, 6, 7 stars in a spine. Now we're not seeing all those, but see these 2 stars? This is my theory, that this is UNIONS 1 that we're seeing there in the middle. See how it got lost and was never, it was just overlooked for all these years. Until, literally, the paper was published in November. So I don't know if you've seen this on another YouTube channel or not, gang. This might be the first time that you've seen UNIONS 1. Isn't this exciting? Okay, I'm going to change our observation here. I'm going to say we saw a grouping of stars that we believe make up UNIONS 1. Faint, but clustered. Around 60 stars in the group. Well, I think that's exciting, gang. What about you? Pretty fun, huh? All right, let's snap a picture of this. Pretty exciting. You know, just to look at it from the APS-C size frame of the ZWO ASI2600MC Pro, it's not going to stand out very well, is it? But nevertheless, it is fun that this was just discovered in August, and we're seeing it tonight for the first time in April. It was just reported on in November, December, January, February, March, April. We're looking at a dwarf galaxy, a galaxy that was just discovered 5 months ago. All right, let's head on to the next object. And for the next object, let's go to Caldwell 83. Caldwell 83. So we're going to put here, instead of saying Caldwell, we're going to provide the, by the way, here's the scope cam. Oh, our scope cam dropped. You know, it's been doing that lately. It's no fun, is it? I wonder if it's because we moved these objects off, there you go, off the screen. When we went to go try to, yeah, there's the scope cam back again. When we went to try to go see the, try to execute that little EAA control panel. All right, so the next object we're going to do is NGC 4945. It's also known as Caldwell 83. Why is that so dark? Do you think it's so low in that direction? Let's, yeah, look at our sky cam. Guess we're pointing into those trees, you think? It's so low. Oh, that's a shame, isn't it? Well, let's try this next object, Caldwell 75. We are not going to be able to get a fix on that. Too low. Let's try Caldwell 75. April 30th. What is wrong with our orientation here? It says it's at 45 degrees. But it's not wanting to slew there. Let's take a look at our, let's go back up to our screen and take a look at our, up here in the upper right, we keep our telescope controls. Everything still looks like the tracking's enabled. Let's try a different object just to eliminate the, let's try going to the Bug Nebula. How about that? So let's abort this slew, I guess. I've never tried using this abort slew button, but it looks like it worked. Okay, slew to object. Now let's try this new. So failed target exceeds a limit. Well, that's odd, isn't it? For some reason. Let's go back to the zero position. And what for us the zero position is back at the North Celestial Pole. Let's make sure we get everything reset. And then we need to figure out why, let's see, April 30th, 2024 at 11 p.m. Ah, I see. We just hadn't refreshed the screen. Yeah. Okay, we do have several objects here, though. Let's try the coal sack. Wow, that would be cool. Or the jewel box. 5, 6. Those will keep rising higher and higher. Best time, I think. Rise at 12 p.m. No, those are actually setting. So let's see if we can catch this globular cluster very low on the horizon. But I think now that we're synchronized, it should work. So we're going to go to NGC 4372. NGC 4372. How about site Emerald Hills? There we go. That helped. Didn't have a site selected. Okay, so none of those are available from this site. Sorry, somehow Emerald Hills had been unselected as the site, and that's why it wasn't working correctly. Here's a globular cluster at 2 degrees above the horizon. Let's just experiment with that and see if we can hit that. NGC 3201. No, it's not going to let us at 2 degrees. Okay, so we'll save this list of objects and go on to a new list. Let's open up the Cosmic Challenge list. How about that? And let's see if there's anything left on Cosmic Challenge that we haven't seen. Now I think we can close this one. Now we're here in Cosmic Challenge. Okay, so these yellow highlighted objects are the ones we haven't observed. And these white objects here at the bottom of this list, these are all the ones we've observed already in Cosmic Challenge. So our time is right, 11:14, April 30th. Let's try going to something to get started and just get oriented here. Let's go to Markarian's chain and pick up NGC 4402 just to get started. Let's connect with the telescope. NGC 4402. All right. Sorry that took a minute to get that all figured out. NGC 4402. All right, I'm going to catch up with you guys over here. Yeah, Larry says tough object. Unions 1. No wonder, it's only 5 months old. Stu, good to have you aboard from Tauranga, New Zealand. Stu's drifting in and out doing some gardening, but here to click the like. He thanked Pete. Dave said, question for the pros. For the supernova T corona borealis, is this something to look for every night or wait until people see it and are observing? You know, Dave, I think that might be available every night. Let's check that next. Okay, we're going to say the mount is settled and it's plate solved. So Markarian's chain is a combination of a chain of like 9 objects in a row. And for some reason, we didn't look at NGC 4402 the last time we were here. So we're going to, just for the sake of completeness, we're going to look at NGC 4402 and the Markarian's chain. Larry says there's an alert system for watching it, but I think once it's exploded, it should be live, right, Larry? It should be visible. So let me put you back on screen. So this is Markarian's chain. You can see it's quite a number of really cool galaxies. I'm going to just go like this and this, and then this and this. See if that helps our... It really didn't very much. Oh yeah, it did. So this is a chain of a lot of galaxies in a row. Excuse me, you can see them there. And what we'll do is we'll turn on deep sky image annotation here so that we can pick out quickly NGC 4402. Okay, maybe not so quickly because there's so many objects in this frame. So help me look if you would. We're looking for 4402. I wonder if I click down here. I've never tried this before. Does it somehow illuminate it? Yeah, it turns it to yellow. Well, that's helpful, isn't it? Look, I'm clicking on down here in the lower right. Let me pull this little applet out here. Notice how we can sort by the ID, and or we could use the name. So sorting by ID, I'm going to click on NGC 4402 and look, it illuminates it in yellow and it leaves all the rest of the galaxy markings in red. So here's 4406, but there's 4402. That is so helpful. SharpCap amazes me. 15 euros is it, or $15 a year? Remind me, I feel horrible that I've forgotten the guy's name who is the developer. Oh, I'm so sorry. Please forgive me. It's just slipped my mind. Ray, if you're still on, you'll know this. Guy from England that's developing SharpCap. Go. Oh, somebody in the audience. We've got 16 of you there. One of you, you're bound to remember who is the developer for SharpCap. I can't remember. Anyway, thanks for the way. Robin Glover, thank you. I knew you'd know, Ray. So here's 4402. So what we're going to do is zoom in on it a little bit, and then we'll get rid of all these little circles so we can look at it. Let's get rid of these. So here is 4402. Look how it's kind of ghostly. Sort of reminds you of that galaxy that's known as the Spindle, doesn't it? But it's not. It's not on any like specialized catalog like Messier, Caldwell, Secret Deep, whatever. It's just another galaxy. But look how we're seeing now some of the dust trails. We're viewing it edge on. You kind of have to tilt your head sideways. And then it looks like a flying saucer from Lost in Space or the Jetsons. Anyway, this is one of the dust trails here in the middle. Let's see if we can brighten it up just a little bit. This object is pretty faint. Let's see if we have a magnitude on this. Why don't we have, oh, there it is, 11.7. Well, that's not terrible. I guess it's because it's, what do you call that? Like it's scattered out. So an edge-on view of this galaxy, and we're zoomed in at 264% of our camera's ability. So it's really just, that's 100% right there. So let's do an observation. I'm going to try this one more time. Quick observation. Pete, I'm so sorry. Evidently, maybe there's been some kind of an update in, could that be an update in Astro Planner that's thrown off our EACP panel? Rats. Maintaining code is as hard as writing code, huh, Pete? This is so much slower, having to do it this way. So this is edge on. Edge on, could see dust trails. So latent. Paul is the programmer for Astro Planner, and I get a lot of latency in Astro Planner unless we use Pete's cool little panel here, but I'm doing something wrong. Or so I see we got about 13 people viewing. Yes, it does show, Ricky, the PGC catalog. You bet. Ray says, I just imaged these galaxies last night with your 8-inch RASA. Well done, Ray. Okay, on to the next target. And what happens then, see, in our observing software now, it has removed the yellow tint from that object, and it has put a 1 here in the observed column. So it keeps track of the things we've observed as we go along. So how about, what would you guys like to look at next? Do you want to look at, we finished off that Markarian's chain. You want to pick up this from the Gamma Leonis group. It's a Hickson compact galaxies or something. Let's go pick up NGC 3185. How about that? So we'll just say slew to object. This is supposed to be 59 degrees above the horizon. NGC 3185. I always like to watch the scope maneuver because I don't know, it kind of keeps us connected to the scope, and since the scope is way outside, 200 feet away, and I'm inside of here, I can't even see the scope from inside my little shirt sleeve office or whatever here. Okay, so it looks like it's settled in there. You can see the weights are west again, and the telescope is Pier-East. And again, the object that we're finding here is NGC 3185 in the Gamma Leonis group. And this is the the number one object in the Gamma Leonis group. Okay, so let's go back to the screen. Mount has settled. And so now it'll plate solve and aim us right at that group. Oh, we were going to go look at that supernova, weren't we? I forgot about that. So let's go there next. It's not on our list here. So I just dutifully went on to the next line and wasn't thinking about that supernova, but we should go to that next. Really appreciate you guys being here tonight. If you want to see content like this, you could subscribe to the channel. Just hit the subscribe button. And if you want to be notified, you can hit, what is it, the bell. And it'll notify you. And only if you want to, only if you like content like this, you could click the like button, and it does get this higher up in the searches that other people do. Okay, every time you have to kind of tune these vertical bars down here in the live stacking large histogram. So you can already see this group even after just 40 seconds. See these galaxies in this group here. This is the Gamma Leonis group. So again, what we'll do is we'll use plate solving to let it solve for this scene. And then we'll put those little hints back on there so that it'll help us identify each thing. 3185 is this. It's a magnitude 12.2. So now we'll take deep sky image annotation off. And we'll know that this is the galaxy we're looking at. Boy, it's tiny, isn't it? Let's see if we can tell what is like the angular extent of this galaxy. 2.3 arc minutes. So again, you've already got this if you've been on the channel for a while, but if you're just new to the channel, remember how the side of the sky that we're looking at, we can see 180 degrees. If you could see horizon to horizon, 180 degrees. You can divide each degree into 60 minutes. So this is now getting into very tiny slices of each. And I guess if you hold your fist out at arm's length, it's roughly, not exact, but it's roughly 10 degrees. So if you took your fist at arm's length and think about it just being 1 degree, now if you divide that up into 60 little arc minutes, this object is 2 arc minutes wide. So it's very tiny. Now we've got this book, Cosmic Challenge, and this is the book we're using as a guide for all these objects by Phil Harrington, The Ultimate Observing List for Amateurs. How about that? And this one is Cosmic Challenge 133. So at the top of each page, it tells us, and this is the section entitled Large Scope Challenges. And Challenge 133 is right here, the Hickson Compact Galaxy Group 44. And then it shows a little map of them. So you can see here are the four galaxies or whatever in this group. And we're seeing here in our picture exactly that. But this is the one we're looking at, the 3185. So now we can see what he says about 3185, if he does. It's found 11 minutes southwest of NGC 3190. He says it's a diffuse glow draws to a slightly brighter core. Yeah. See how it's a diffuse glow and it draws to a slightly brighter core. There went a satellite. Zoomed right by it. The northwestern appears to just kiss a 14th magnitude field star. That would be this in the path of that satellite. That star is well within the Milky Way, however, so be sure not to mistake it for an extragalactic supernova. Okay. Okay, so let's click New Observation here. It says no date and time. Wonder why that is. Oh, I see. If you click no date and time, you would do an observation that's not associated with this time, but we want it to be associated with this time. Added to the currently open session. That's odd. Okay, so we're going to say 3185. Was a diffuse glow giving way to a slightly brighter core. Wonder if it's got a bar here. Might have a bar across it there. Look at this big dust lane across that galaxy. Pretty cool, huh? Well, we miss Tiffany here. She always keeps the crew nice and lively over here, don't we? She's like the room hostess over there, checking in with you guys when you log on. About 10 of us on here. This is definitely Team Astronomy. All right, let's hit the next object. Again, we're trying to pick objects from that we haven't observed yet. Here is an object called J900. It's a planetary nebula. J900, Jonquière 900. That's kind of an exotic object, isn't it? So let's hit that one. Except it's not letting us because it's just 11 degrees above the horizon. Now, why would it not let us do that? Maybe we haven't refreshed. It's entirely possible that we haven't refreshed and it has sunk while we, that's probably what happens. So we need to keep refreshed. All right, let's go to wow. You know, another thing I miss about our little EAA-CP panel that Pete designed for us, this little applet here. I miss it because it lets you record an observation for a bunch of objects all at once. Log an observation. Wonder if that would work. Control 9. That works. Let's do that. So from now on, we'll use Control 9 for this, and it'll be much quicker. Okay, so this is Abel Coma cluster. Oh, and you can add it to 87 associated objects. Wow, that's awesome. Let's say cancel for a second. Get rid of this. put the right name here. Abell 1656. It has settled. So this is the Coma cluster. It's object number 164. Yes, Tiffany messaged today and said she hoped to be on tonight. Like I say, she definitely welcomes everybody. Okay, so this Abell Able Galaxy Cluster deal is an amazing group. Did we slew to this? Because that still looks like the same Hickson group. I don't think we did. Let's try this again. There we go. Now we're slewing to Abell 1656, also known as ACO1656, or the Coma cluster. Now, to give you an idea of how busy of a place this is, I'm just going to show you Harrington's map here. I think you can see that over on the right-hand side of your screen while the telescope is slewing. But I could also enlarge it here. Look how many different objects there are in view in this one satellite cluster. Abell 1656. Well, there are a lot of moving parts in this operation, aren't there? I think if we were to simplify electronically assisted astronomy down to its very smallest common denominators, you would have a telescope, in other words, the optical tube assembly, or some people would say OTA. You'd have a camera, a mount that can track the sky. In other words, as the Earth turns, you know, we have this appearance of the sky moving across our vantage point. But really it's because we're turning. And so you need a tracking mount, the OTA, the optical tube assembly, a camera. Then you need software that can stack, live stack these images. And that's part of the magic. You know, right now you're looking at the screen and look, this is maybe what a person would see through a telescope with an eyepiece. But when we start playing with this live histogram, now you start seeing a bunch of tiny fuzzy things in the picture. And each of those fuzzy things is a different galaxy. And to visualize this, it helps to use Robin Glover's deep sky image annotation, because it's really a quick way so that you can get the big picture of just how many objects we're looking at here. Each one of these is a different galaxy. And in one single glance, you're looking at galaxies that are maybe like the Milky Way, but maybe millions of light years away. Let's see if we have some distances here figured out. None there. I wonder if we have some over here in Astro Planner, but none here in the book. Distances are tricky with a lot of galaxies because we don't really have a yardstick long enough to measure how far away they are. maybe in some of the text, he might give us an idea. So how do we figure these distances? I mean, we use things like certain variable stars that have a particular cycle. We can watch that cycle, and that gives us a clue of how far away it is. But these are far enough away that we can't use the other way, which is called parallax. That is, you take an angular reading in January and take another angular reading in July, when the Earth is on the other side of the sun. But that distance is not large enough to yield any difference in angles. In other words, the baseline to calculate the geometry. We can use it for close things, but that baseline is not big enough to calculate the geometry for these galaxies. So maybe in the text he'll tell us here in a second, but nothing leaps out at me. Okay, so maybe in the neighborhood of 60 million to 300 million light years away would be all of these. So let's just go down through a quick list of them. Here's Caldwell 35. There's IC839 up here, very tiny. IC842. See that. It's yellow somewhere on our screen, but I'm not seeing it. And there's 3943. Maybe we're zoomed in a little bit too, no? Too much. Maybe this is approximate field of view. 3947, 3949. Most of these are like sub-arc minute sizes, very small. IC 3957. These are different catalogs, whether it's an NGC or an IC number. 3959, 3960, and the list goes on. So this whole thing is this coma cluster. So now what we'll do is we'll go Control 9. Control 9. It didn't work. There it is. This galaxy cluster is in and of itself amazing. So many tiny island universes. 87 different objects. And in one click, we entered an observation for all of them. It's pretty crazy, isn't it? It takes a while to enter it. ASIO1656. This is the Coma Galaxy Cluster, spanning an area twice the size of the Leo cluster and holding more than 800 galaxies brighter than 16.5. It's a real galactic forest. You will never get through this huge collection of galaxies in one sitting. He says, where to begin? He talks about them in groups of how faint they are.
Observe.
He adds that what he's writing isn't even the tip of the galactic iceberg. Uh-oh, Astroplaner just crashed. What do you think of that? Too many observations at once, you think? Too many for it to handle? So what we're doing here is trying to restore Astroplaner, which is the software used for target listing, but it has decided that it wants to be a little cantankerous. Okay, I think we're back now. Now once it's dropped like that, we have to reconnect to the telescope. And then let's find the object we were seeing, which was able, wasn't it 1656, I think? Maybe it listed observations for it all, and so that's not why it's visible. Pretty sure it was 1656, I think. Let's do this. Let's sort it by the ID. It's a lot of objects. 1,001 plus. There we go. We're looking for 1656. Huh. Here we go, 1656. I don't know if it finished all. It was object 164. So let's remove the highlighting for a minute and just put it in order by cosmic challenge number. Aha. Nope, it did. It put an observed marking in all of them, exactly like Pete hoped that it would. So that's good. I think since we had to reopen Astroplaner, we're going to have to go up here under Edit Run Scripts And we're going to have to run that script again that we're using. We'll try to watch whether or not we do 89 objects at once. Log an observation. Okay. Just gonna make a note of this to make sure it
Observation log.
It did. Okay, let's go back to highlighting our not observed objects. And I think that the sort is supposed to be arranged by the best time. Let's go here under sort list. And let's say visibility. We're going to sort by visibility and then time. So we know when they rise and set. How about that? Okay. Now we've got our list of things to observe. Let's go to NGC 2475. Oh wait, we were going to look at that supernova. And it was called which supernova was it? Supernova T Corona Borealis. Let's make sure we can find it first in a browser. Supernova T Corona Borealis. Wow, that's a pretty vibrant explosion, isn't it? 3,000 light years from Earth. Looks like it's right in the keystone of Hercules there. So why don't we go to Stellarium and just try searching for T Corona Borealis. It's there. So that's it. Blaze star. Okay, so now to get T Corona Borealis. Let's open up that script I use called the wish list. And let's hit the plus sign and then say T Corona Borealis. How about that? It's not finding it. Let's try looking in Simbad. Simbad is a listing of objects over in, I think it's Austria. Boy, it doesn't seem like that stellarium made very much of it. Blaze star. Let's try it. So now normally we would transfer this back over to Astro Planner, but in this case, let's just use stellarium to point the telescope. We do that with, in stellarium I have that macro set up from the plugin. I have it set so you can go Control-0, I think. And it brings up this little, what do you call this, like a little applet. And I'm going to say current object slew. Or are we live stacking over here? It's going to make that a mess. So let's save the live stack and then go to next. Target. And however you want to put that in, I guess we could put it in as T Corona Borealis. Settled. So inside of that galaxy, maybe we should go focus first, you think? Let's go focus. So we're going to stop live stacking. Default next target. And we have to unplug the camera, sadly. Bring up Nina. We use Nina for autofocusing. Stop. Okay. Disconnect the camera. Now go to Nina. Nighttime Imaging and Astronomy, I think it stands for. Way over there. Load the profile. Turn on the camera. Turn on the focuser. Go to imaging and click Start Autofocus. So again, you guys are on the channel for a while. You've seen this before, but if you're new to the channel, welcome. We use Nina for autofocusing because what it does is it takes a picture of the sky and then calculates the luminosity of the stars, a half flux radius, which is just a fancy way of saying luminosity, if you ask me. And then, by the way, it captures two and averages them. Then it moves the focuser a little bit out in one direction. And it moves it to a new spot, like 40 stops away in the camera's complicated movement orientation. And it takes two more pictures and averages them and starts comparing them to the first picture it took. And if the two new pictures have a smaller half flux radius, a smaller luminosity, then the software decides, okay, we're going in the direction of the best focus. And it can just keep doing that over and over again, moving another 30 stops, taking two pictures, figuring out whether or not the focus is better in the original or in the second one or in the third one. And this just goes on and on and on and on and on. So finally you get a comparison of all the focuses, and then comes the hard part. The navigation software inside of Nina, it's sort of like navigation software in that it says we're going to use the smallest pinpoint of light possible. So what point was that? And it scours through all of its records and it says, okay, that's the new focus. If it moves past the sharpest focus, the smallest subroutine, then you sometimes have to keep taking pictures until it comes out of focus in the new direction, and then bring the camera back to the middle or to the place where the focus is best. Bottom line, it's using the very camera that we're viewing to establish proper focus so that you can then go back to SharpCap and enjoy looking at the object. But Nina is really designed for an astrophotographer's set of tools. It's not as good for live observing as what SharpCap is. So you can see it's now starting to bottom out in that parabola. And that means this is the sharpest focus. It'll do, I think, 2 stops farther once it's established that curve. And the 2 stops farther, you get out there and it realizes what you're doing. It moves the focus back to that middle point where the focus was best. So it's all automated this way, and especially with a RASA, the thickness between focal points that you're trying to make sure it stays in focus for, it's equivalent to, like, I don't know what to compare it to, but think of the sharpest, most liquid image you can imagine, and make it look like the best possible image. And that's I suppose that's exactly what we're going for here in Nina. And the way you know that it's over is because this red bar changes back to start imaging. Now there was an aberration here. That could have been a cloud. Let's go back over to the sky view. There could just be some occasional clouds, although we don't see any there, do we? No clouds. Here's the Big Dipper off to the right. But no clouds. But that's a pretty mean-looking parabola, isn't it? Had to be something that it stumbled across here. So when it stumbles, it is aware that it stumbled. Larry says, I'm trying to decide whether to spend some more money on and automate or sell everything and give up. My eyes and skies aren't cutting it. Well, Larry, of course, you're always welcome to observe with us, but boy, I hate for you to have to give up if you love the hobby. Ray says, maybe I'll do live stacking one day. Well, I hope you do, Ray. I know you'd love it. Got those two berserk readings, don't we? Otherwise, it's a pretty predictable parabola, isn't it? Just two readings off. I'll tell you what, while we're here, let's just run this one more time, just to see if we can improve on that any. All of this stuff, you know, the OTA, the optical tube assembly, in other words, the camera, the mount, the software, all this stuff has to work together. And boy, if you get off on one of the pieces, it's just not a fun sight. So you have to make the technical pieces like the optical tube assembly. You have to make all that fit with the soft parts of the system, which is the for example, sharp cap, let's say, which basically is a glorified, it's a glorified picture taking system is all. But it's just made for what we're doing, live stacking. It just is made for that. Whereas something like Nina is made for automating the astrophotography hobby. I cannot get Nina to work for EAA. Maybe you've been able to do that, but so it's like a two-step dance for me. I focus in Nina and then go to sharp cap afterward. It's odd that the histogram, live stacking histogram panel stayed on there. Ray says, that's why I only take single pictures. It focuses faster. Larry's talking about, I'm trying to decide whether to spend more money and automate or sell everything and give up. My eyes and skies aren't cutting it. I think it's true with a lot of us, Larry. Our eyes have a harder time with the eyepieces, but I really think that looking at a screen for observing through EAA is no different than looking at a screen to create some kind of picture in Word and Photoshop. It's the very same idea. You're just looking at a screen of a set of images. So if you can look at the screen and if they can tune your vision well, then surely I don't think you should let your eyes, I think you should just observe whatever you can while you can. So we've got about 16 people on the stream live, plus those of you who are watching the recorded version. We try to do this about once a week, sometimes once every couple of weeks, but it really is at the mercy of the skies. And we use software. I guess that's kind of the trend, isn't it? We use a piece of software to help us predict what the skies are going to be like. It's called Clear Outside. And you can set up Clear Outside so that your own longitude and latitude are saved, your GPS coordinates. And this is the software we use. So you can see tonight, we've got this stretch of darkness here in which there was no moon. The moon doesn't rise until, what, 3:11 a.m. So there's no moon, and these red blocks, or is that salmon? I don't know what color that is. Those represent varying level of clouds. So the red might be 80 to 100% cloudy, and the salmon might be 50 to 80% cloudy. But see, we've got this green patch here. Now look at the rest of the week. I mean, there's 1 hour that's supposed to be a little bit of clarity in the sky, so it's not socked in with clouds. Otherwise, this week is shot after tonight. So that's why, if you wonder sometimes, why do you do this on a work night? We just have to take the time that we're given, you know, because we're at the mercy of clouds, aren't we? Now that you've got the Webb Space Telescope or Hubble, it's a little easier for astronomers that are working those pieces of equipment. But our RASA is not in orbit. Now look at that parabola. That's much better, isn't it? So now all we have to do is go back to equipment, disconnect the focuser, disconnect the camera, go back to SharpCap, reconnect the camera, make sure the mount is still connected, and it is. That's over here in this panel. And we were going to look at this supernova. So now let's start imaging again. Now, while that's getting started, let's go back over to that article. Here. A star system located 3,000 light years away from Earth is predicted to become visible to the unaided eye soon. This could be a once-in-a-lifetime viewing opportunity. The nova outburst only occurs about every 80 years. T Corona Borealis, or TCRB, last exploded in 1946. And astronomers believe it will do so again between February and September 24. This is showing you a sketch of the sky. Let's go back over to, while SharpCap is live stacking, let's go to Stellarium and search for this. T Corona Borealis. So that's it in the middle, the blaze star. This is the telescope indicator. But this is the field of view. Okay, so we're settled in here. Let's give ourselves a little bit more darkness to just create a sense of the dark sky. Then let's bring up the mids a little. And we're looking for how will we know when we found this? Where will T Corona Borealis be located? In the horseshoe-shaped constellation called Corona Borealis, about 3,000 light years away. I would have thought it would have been in a galaxy, wouldn't you? It's supposed to be the brightest nova of the generation. So here's Astronomy magazine. Does it just, surely it doesn't just appear, maybe since it's a nova, not a supernova, maybe novae just pop up in the middle of places. How will we know if it's glowing? Located near the constellation Hercules. Corona Borealis, and here's Hercules. The crown's brightest star is Alpha. Okay, so that's where it's going to occur. So here's the crown, and if you extend that line, maybe equal to one more star length roughly. And this looks like a gun sort of pointed down at it. Okay, so let's go look at the live view again. Wait a second. 1, 2, 3, 4 sides. 1, 2, 3, 4, 5. Now the live view. So this This is probably a bigger view, isn't it? So the question is, how will we know where it will pop out? My friend Pete would be able to tell us this. So let's do our human plate solving. We're supposed to be on it here. It's the blaze star right there. And this is supposed to be our field of view. So we should have 2 bright stars here and 3 bright stars there. Let's get rid of this. That's not helping us. Boy, are we sure we're looking at the right thing? But we're not. Oh yeah, we went to it through Stellarium, so we should be. So here are, look at this line of stars down here. 1, 2, 3, 4, 5 in a row. So that might be this, that row of stars, you think? And we're just reversed. Of course, here's another row. 1, 2, 3, 1, 2, 3. My friend Pete calls this human plate solving. These are particularly bright, and look, it makes it, it's like forming a triangle. 1, 2, 3, 1, 2, 3. And then inside it has an interior roof. Let's look for those. Anybody see that? I don't. Larry, was it you wanted to see? I'm trying to remember. Dave. Dave, are you still with us? Help us out here, Dave. We should have that bright star in the corner of our image. Let's stop live stacking for a second. And let's do 3-second images again. And a gain of 400. And let's plate solve one more time to make sure we're looking at the right part of the sky. Ah, so we didn't plate solve after we moved using Stellarium. That's the problem. Okay, now we should be looking at the very same frame. except it's probably going to be a little cockeyed still. Now look, here's the possibility of that triangle roof, huh? Think? 3 stars and 3 stars? No. What about this being one of the sides of the triangle roof? And then that's 3. Three stars, 3 stars. 3 stars, 3 stars. Here we go. Now this blaze star is supposed to be a little off to the left. 3 stars and 3 stars. If we're looking at the right place, I'm not seeing it. So you can see that this web page that we were looking at, TCRB is a green dot. When it goes off, it'll only be a maximum brightness for a half day before you must wait for another 80 years to see it with your naked eyes. Magnitude of 10. Well, we're coming up on 12:30. I wish we could have settled this for you. Dave, there you are. We're trying to find your nova, and what we're looking at is it should be a magnitude 10 right now. So one idea is, let's bring up a more like, maybe a more, you think, a higher powered atlas? Or should we, do you think we're going to be able to find it using Stellarium's atlas? Because we're not seeing very much of a correspondence here, are we? Between the two images. Here would be 6 stars in a row. I suppose it's possible that that's that. See those 6 stars here. Probably not very bright. But then again, these wouldn't have to be very bright. Right there. So maybe like right here. How about that star? Somebody help me, is that green? Because for some reason it says it's kind of greenish. Why is a star green? You know, when the did we drop off for a second? There is a script here, SharpCap DSA. Let's try running that. and see if we can run it without errors. Pete also programmed this. Thank you, Pete. And if it'll work, it's compiling.
DSA completed.
Control 2. Something seems a little bit off on this. Yeah, Astroplanner died. That's sad.
DSA completed.
Yeah, I don't think that's running. I was going to copy the coordinates using that and then put them into SharpCap, but it doesn't appear to be working correctly. So we'll keep an eye on this, and when it does erupt, for sure we'll find it then, but also we'll come back another night and we will have figured out what's wrong with the script, and that'll help us locate where this star is that's going to go nova. That goes nova every 80 years. It's this blaze star, V asterisk T Corona Borealis. And we'll come back and do an updated live stream on that. Okay? Okay. Well, thanks for being with us tonight. Kind of picked up a couple of loose ends. Getting back into the muscle memory of doing this again. Thanks for being a part of this. Got some observations in, chipped away a little bit at the Cosmic Challenge. If you've been here with us, thanks for watching. You're a faithful observer if you've been here through the whole time. Don't forget to subscribe. Click the bell if you want to be notified. And if you like content like this, hit thumbs up. Thank you guys for being with us. About a dozen people we've had all evening. And we are appreciative of you guys. Thank you, Larry. Larry's saying thanks for the show. Thank you guys for observing. This is, to me, it's exciting to learn to use this gear and learn to see the stuff that's up there in the sky all the time. We just take it for granted. Thanks to God for making all these amazing objects. And to you guys for being a part of this. Astronomy is a team sport. God bless. Have a great